Good morning, sir. My name is P. Arvind. I am from Mechanical Engineering. My roll number is 234G180302. Today, my topic is translation and rotation, kinetics and kinematics. Introduction to translation and rotation. Translation and rotation are fundamental concepts in geometry that involve moving objects in space. Translation refers to moving an object without changing its shape or size. Rotation involves turning an object around a fixed point. Translation. In translation, every point on the object moves the same distance and direction. This movement is described by a vector that specifies the direction and magnitude of the translation. Translation can be horizontal, vertical, or diagonal. Properties of translation. Translation preserves the distance between any two points on the object. The orientation and shape of the object remain unchanged after a translation. Multiple translations can be combined by adding their respective vectors. Rotation. Rotation involves turning an object around a fixed point called the center of rotation. The angle of rotation determines how much the object is turned. Rotations can be clockwise or counterclockwise. Introduction to kinetics and kinematics. Kinetics and kinematics are two branches of classical mechanics that study the motion of objects. Kinetic focuses on the forces that cause motion, while kinematics describes the motion itself. Understanding the relationship between kinetics and kinematics is essential in any movement of objects. Mechanics, dynamics, statistics, kinetics, kinematics. Equations of motions in kinematics. The equation of motions in kinematics include equation for displacement, velocity, and acceleration. The most common equations of motions are derived from calculus and are used to describe the motion of objects in various. These equations form the basics for motion solving problems related to motion in kinetics. V is equals to V naught plus AT. X is equals to X naught plus V naught T plus half AT square. Equation 2. V square is equals to V naught square plus 2a into x minus x naught. Equation 3. X is equals to x naught into V naught plus V by 2 into T. Equation 4. Position x. A quantity which describes the location of the object in 1, 2 or 3 dimensions. Velocity v. A quantity which describes the change of position with respect to time. Acceleration. A quantity which describes the change of velocity with respect to time. Newton's law of motion. Newton's law of motions are fundamental principle in kinetics. The first law states that an object at rest will remain at rest and an object in motion will remain in motion unless acted upon an external force. Applications of kinetics and kinematics. Kinetics and kinematics are essential in various fields such as engineering, physics, biomechanics, and sports sciences. Difference between kinetics and kinematics. Kinematics deals with forces causing motion, while kinematics describes the motion itself. Kinetics involves studying interactions between objects and forces, while kinematics focuses on the motion's parameters. Understanding both kinetics and kinematics provides a comprehensive view of the dynamic motion. These principles play a crucial role in development technologies and advancing our understanding of the physical world. Thank you.